So we want to identify if this is a polynomial function. If it is a polynomial function, then we need to state the domain. So let's start with the function f of x equals x to the power of 5/4 minus x cubed plus 9. So when you're identifying a polynomial function, there's 3 rules you have to follow. You focus on polynomial functions have no fraction exponents, they have no negative exponents, and they don't have any absolute value. So as you can see here, we have an exponent of 3 and we have an exponent of 5/4. Because we see a fraction in our exponent, this is going to be not a polynomial. And the reason why it's not a polynomial, because we have a fraction in our exponent. Now if we look at the function f of x equals 4x plus 6x squared, well, it doesn't have fraction exponents, it doesn't have any negative exponents, and it doesn't have any absolute value. So we can make the conclusion that yes, it's a polynomial. If it's a polynomial, we have to state, not the degree, let me correct that. I put domain, but we should state the degree of the polynomial. So we try to state the degree of the polynomial. And remember, to find the degree of the polynomial, the degree is the highest power of your polynomial. So if you look at here, there's no number there, but it's understood to be a 1. So the degree here is 1, and the degree here is a 2. So you take the highest exponent is 2, so this is a polynomial of degree 2. So now let's use the leading coefficient to determine the end behavior of the polynomial function. So we know this is a polynomial function. Now we need to identify the end behavior. Remember, the end behavior is basically telling us whether it goes up or down on both ends when we're sketching the graph. So to find the leading coefficient, that's basically your A. Your A, it's your leading coefficient. So it's basically the number that's leading our polynomial. In this case, our leading number is -3. That's one piece of information we need to use. The other piece of information we need to use to find our end behavior is the degree of our polynomial. On this one, it was a matter of just looking at it and taking the highest exponent. Here, it takes a little bit more work because as you can see, in between each of our factors, there's some multiplication going on. So in here, we have an x, but this x is eventually going to get squared, and we're multiplying by another x, but this x is eventually going to get cubed. So if you think about it, you're going to end up with an x squared times an x cubed, and when we multiply same basis, we add the powers. So we end up with, this is a polynomial of degree 5. So now, this is how we identify the end behavior. You look at your A. Is your A positive or negative? In this case, our A is negative. And then you look at your degree. Is your degree an even or odd number? So in this case, we have an odd degree. Even degree polynomials go on the same direction. When you're dealing with an odd degree, that means your end behavior is going to go in opposite directions. And your A is the one that tells you which way it goes. Because our A is negative, I know my left-hand side is going to go up, and I know my right-hand side is going to go down. So the end behavior for this polynomial function is going up on your left and going down on your right.